Picture this. You've spent months, literally months, crafting an absolute masterpiece out of discarded materials. You put it on display, and then it starts to melt or rot or maybe even release toxic fumes right in the middle of a gallery. Yikes, right? To really master sustainable art, you can't just be a collector of interesting trash. You kind of have to become a rogue material scientist. Welcome to this explainer. Today, we're diving straight into the exact steps you need to rigorously test how unfamiliar materials behave, respond to your tools, and ultimately carry meaning. Let's get into it. There is a core philosophy here that every responsible maker absolutely must adopt, and it comes straight from our source material. Copying a process blindly with found waste is a total recipe for disaster. I mean, think about it. If you see someone melting a detergent bottle or carbonizing timber on social media, and you decide to just mimic them without understanding the temperature limits, the toxicity, or the required ventilation, you are putting yourself and your artwork at serious risk. True material literacy, it means asking the right questions before you ever make that first cut or light that first match.
Here's our roadmap for today's explainer. We're going to cover 5 key areas: the unpredictable canvas, setting the stage, the material menagerie, the power of the logbook, and finally, making the final call.
Starting off with Section 1, the unpredictable canvas. This is where we shift our mindset from random trial and error to intentional discovery.
Now, you might be wondering, what makes waste so different? Well, think of conventional art materials, like your standard paints or modeling clays, as obedient pets. They're predictable, they're stable, and they have a safe, fixed function. But sustainable waste materials, like construction debris or discarded packaging, they are completely feral. They were never meant to be art. They might shrink, release toxic fumes, melt, or literally decay right in front of your audience. Because they're so unpredictable, they demand a much, much deeper level of material literacy from us. Moving on to Section 2, setting the stage. Let's talk about how a responsible maker actually preps before touching any of these wild materials. So, your absolute best friend in this process is the controlled material trial. This is basically a small, carefully planned experiment where you test just one material or process at a time. Let's be real, many sustainable materials will fail, and it's way better to have a catastrophic failure in a tiny, safe studio trial than during a massive public exhibition. A controlled trial isolates exactly what causes a material to react, protecting you from wasting precious time or creating dangerous conditions. But before that trial even begins, your workspace needs to look a bit less like a traditional studio and a bit more like a laboratory. Essential prep means proper ventilation, highly organized spaces, and the right protective gear, masks, eye protection, the works. You also need process-specific tools like heavy-duty clamps or scales. You can't just grab whatever's convenient. And absolutely crucial is this strict rule: isolate one variable at a time. If you change the heat, the binder, and the drying time all at once, well, you're never going to know what actually caused your result. All right, Section 3, the material menagerie. Let's take a rapid tour through the specific waste materials we can actually test and transform. First step on our tour, organic materials. Things like banana fiber, rice husk, or leaves. These are great because they connect beautifully to ecology and natural cycles, but they definitely bring unique challenges. You've got to monitor them closely for moisture, fungus growth, and rapid decay. Because let's face it, what happens if your brilliant organic sculpture starts smelling like damp rot in the middle of a gallery? Not ideal. Drying them thoroughly, and actually timing how long that takes, is your first line of defense. To put that into perspective, let's look at a controlled trial using sago waste. If you track 3 small samples, the revelations are honestly huge. Say you leave it raw, it stays unstable and risks growing fungus. Mix it with an adhesive, you get a strong texture, but the edges might crack when drying. But if you burn that waste into ash and mix it with a binder, boom, suddenly you have an entirely new, stable filler material. Just changing one single variable completely redefines what the material can do. Next, we have plastics. Now, discarded consumer plastics carry incredibly strong messaging about everyday consumption. But you really have to ask yourself, can this specific plastic be cut safely? What toxic fumes are released if it melts? Heating plastic should literally never be a casual studio experiment. Different plastics shrink, become super brittle, or release highly toxic fumes. If you're going to use heat, you need strict knowledge and serious ventilation. Honestly, safer methods like weaving, stitching, or color sorting are usually just as conceptually powerful without the respiratory risks. Then we have timber and construction residue. These materials speak volumes about urbanization, but they require intense physical caution. You have to watch out for hidden nails, termites, and dangerous concrete dust that you definitely don't want in your lungs. A really popular aesthetic technique right now is carbonizing or burning timber surfaces. It looks absolutely amazing, but you have to constantly balance that visual beauty against the very real dangers of fire, smoke, and potentially making the wood too fragile to even support its own weight.
On a slightly lighter note, paper and packaging waste offer incredible versatility. You know the drill. You can cut, fold, weave, and pulp them. But here is where it gets absolutely brilliant. Everyday Tetra Pak packaging has layers of paperboard, plastic, and foil. Artists can actually use this trash as an alternative dry point matrix for printmaking. This is a real game changer because it proves sustainable materials aren't just for the final artwork, they can actually replace the conventional tools used in the production process itself. And rounding out our menagerie, we definitely can't forget fabric waste. Old clothing or discarded upholstery brings this beautiful softness of memory, cultural identity, and stories of domestic labor to an artwork. It completely expands our sustainability experiments beyond just hard plastics, concrete, and metals, letting us test things like stitching, patching, and soft assemblage. All right, moving into section 4, the power of the logbook. Because without this, your experimentation is just playing around. A logbook systematically captures your entire journey. And it's not just about jotting down what you did. You need to log the exact source and initial condition of the waste. You've got to record your sensory observations. Did the smell change? Did the texture shift from soft to brittle? And absolutely crucially, you need photographic evidence of the material before, during, and after the process. Doing this transforms a chaotic studio session into usable, repeatable data. And this brings us to a massively important mindset shift. In a controlled trial, failure is not a ruined artwork. Actually, scratch that. A documented failed test is simply gained knowledge. If a piece of wood cracks in half or a plastic melts into an unusable lump, you haven't failed as an artist. You've just proven that a specific process doesn't work for that material. And having that data is exactly what prevents a total disaster during your final public exhibition. So, to put this all into practice, think of it as a fluid 6 step workflow. You identify the source, gear up safely for just one process, run a small physical test, and then rely heavily on your senses to observe the results. By photographing every single stage, you give yourself the exact data you need to reflect and plan your next adjustment. It completely condenses all your planning, observation, and reflection into one highly manageable cycle. Finally, we reach section 5, making the final call. This is the climax of the process, where we move from testing into actual artistic execution. After running all your trials, you sit down with your data and face the hard truth. Does this material actually support your concept? Does its behavior clearly communicate the environmental or social issue you're tackling? And even more importantly, is it truly safe to handle and display? Because if a material is conceptually brilliant but physically unstable or downright dangerous, you have to use your evidence to pivot and adjust your direction. You are the one who chooses what moves forward and what gets rejected. Ultimately, mastering sustainable art requires a massive shift in ego. As we wrap up this explainer, I want to leave you with this provocative thought to guide your future creations. Are you constantly dictating what this material has to become, or are you actually listening to how it behaves? The goal is never to force waste to obey you like conventional paint. It's about developing a respectful relationship with the material. Stay safe, document everything, and keep experimenting.